Hi, everyone. Thank you so much for joining us today to talk about BRUIE and underwater rover. I'm so excited to learn more about this endeavor, and I hope you are too. So I just wanted to get us started with an icebreaker question to get that chat going. So go ahead and type into the chat, what life forms do you think we will find beneath the ice on the ocean moons of Saturn and Jupiter? That's one to think about. So think about your answer and then type into the chat, what life forms do you think we will find beneath the ocean moons, beneath the ice on the ocean moons of Saturn and Jupiter? And I'm reading the chat here. We've got some folks joining in. Steven says whales and squids. I hope we find whales and squids. That would be really cool. Aaron says fish-like creatures. I think that's a pretty good guess. Colin says bacteria. Lydia hopes we at least find bacteria. I do too. Oh, and Alexa says we might find the creepy cousins of cyanobacteria. Oh, lots of great guesses. Oh, Collins adds water corgis. Miranda is being a little bit pessimistic and says we won't find anything. So hopefully that's not the case. Well, y'all can keep typing into the chat. I'm going to go ahead and do a quick Zoom tutorial for those of us that are joining in Zoom. So here is what your screen might look like if you're joining in Zoom. You will want to be in speaker view so that our guest speaker is highlighted for you the whole time. When we start to share our screen, you might see our video over the slides that we want to share. If you do see that, just go to the top and click View Options and go down here where it says side-by-side mode. We do have captions available for this program. You can enable those by clicking the closed caption button at the bottom of the screen and then click Show Subtitle. And then, of course, whether you're joining us on YouTube or on Zoom, we would love to hear from you. So please use the chat to ask questions and make comments. Just remember to be a good digital citizen, so be on topic and be very respectful to everyone else who's in the program. So with that, I'm going to go ahead and introduce our guest speaker. I'm so excited. We have Jeff Qualls, a NASA and JPL Solar System Ambassador. So Jeff, are you ready to go ahead and share your screen?
Yes, I'll do that right now.
Okay, and let's see, Jasper's adding, we're gonna find microbial life, and we've already got a question right off the bat. So we will be taking questions. We're gonna save them for a break in the program, but we will be taking questions later on. So.
All right. Here we go. Let's see. All right. Hi, everyone. Thank you very much for taking time out of your day to join this little presentation. I hope that that you've had a chance to do some of the other Astronomy Days presentations that have been going on this week and today. And if you haven't, there will be some more tomorrow, and there's some really good ones. And the good thing is that if you missed some of the ones that you wish you had seen, that they'll be available for streaming later. So you can just go onto the Astronomy Days website and pick and choose which ones you think you'd like to view. Today, I wanted to talk to you about something that is kind of a bit out into the future of solar system exploration, but I think it's an exciting concept and something that's fun to talk about. And if we're lucky and we live long enough, we'll get to see this happen in real life or something like it. This is a really cool engineering project called BRUIE. It's going to be an underwater rover that you may see someday exploring the ocean moons of Saturn and Jupiter. I'm not an engineer myself. I really admire engineers, and maybe I'll be one in my next life. But I just like the way you give a really complex problem to an engineer, and it's like giving candy to a baby. It's like They love it, and they want to figure it out from top to bottom and turn it inside out until they can solve it. And exploring under the ice crust of our ocean moons presents a whole raft of problems that can only be solved by some really brilliant engineers. And I'm going to talk to you about I'll talk to you about several of those problems actually, but the main one is how we're going to explore once we get below the ice on those worlds. Now, the worlds we're talking about, there are a good handful of them. The main ones I'm going to kind of be speaking about today are Enceladus, which is a very small moon of Saturn, and Europa. And Enceladus was, before the Cassini mission, thought to be a pretty uninteresting place and not any place we were going to spend a lot of time exploring, because everybody thought it was just like a big snowball in space, just ice. And when Cassini flew by the first few times, when that mission was going on in the 90s and in the 2000s, they noticed some weird readings from some of their experiments, so they decided they needed to go back and figure out what was going on. It was like Enceladus had an atmosphere, but it's too small to have an atmosphere, so they were like, well, what's going on there? So they sent Cassini closer in flybys of Enceladus, and they found that the ice geysers that you see on the picture on the right side of your screen. Well, that was revolutionary. They had never contemplated that something like that could be going on there or really anywhere else. So they did not have instruments on Cassini that were specifically designed to try to get to sample what's in those ice geysers, but they decided that their spectrometers could at least give them an idea of the composition of those things. So they actually flew Cassini into the streams that were coming up from the surface and found out that there was organic material in there, and it was like salt water, really, that was freezing as soon as it hit space. And there's enough of those ice geysers that are spewing material out into space there that they actually form a very, very thin, almost translucent extra ring of Saturn. So that's pretty cool. The other moon I just mentioned is Europa, and it's been found in we've only sent we sent 3 probes out to Jupiter. Voyager went by a couple of times in the 70s, and Galileo. Juno is there now, but it does not go past Europa very much. So we aren't learning a lot about Europa from Juno. But as you can see in the picture on the left, there's a lot of cracking that's gone on in the ice on the surface of Europa, and all of that reddish looking stuff we believe is organic material right there on the surface. And on the right, you see an image that was taken by the Hubble Space Telescope, and it looks like there are plumes coming out of Europa too. So we are in the process of sending a mission out to Jupiter called Europa Clipper that will make 50, 60 flybys of Europa during the lifetime of its mission, and its goal is to learn a lot more about Europa than we know now. Map the surface in its entirety, use radar to try to see how thick the ice shell really is, to see if there are any thin places where we might be able to get through the ice. And that's a real important step before we can ever send anything up there that's going to try to explore. So that's coming up, I think, in 2025. It's going to launch, and it'll take a few years to get there, but that's an exciting thing to look forward to if you are interested in Europa exploration. So anyway, we're here today to talk about BRUIE, which is a buoyant rover for under ice exploration. That's what that acronym means. And you may have seen some concepts for how to explore under that ice in the warm oceans before, and some that I've seen involve like submersibles, like we send down to look at the Titanic on the bottom of the ocean floor or whatever, like little mini submarines almost. And that's an interesting concept, but it creates its own sets of problems. Like how do you keep control of that probe, against currents? How do you have enough power supply in there to enable it to explore for a long period of time? And the engineers on this project looked at the problem of exploring down there, and they thought about where does life exist in our own oceans, and it really exists plentifully down on the ocean floor where the water meets the floor of the ocean, and also up at what they call the ice-water interface, which is where the water meets that ice shell in the Arctic and the Antarctic. So they thought, well, why don't we just invert this? So instead of having a rover that roves around on the surface, it's going to actually rove on the ceiling of the ice, where the water hits it. So, most of us wouldn't have been able to think outside the box to that extent, but that's what these guys did. And they came up with a pretty ingenious concept, which is BRUIE, that uses buoyancy to keep it up against that ice ceiling, and it can actually move around on the ice ceiling like it's driving on a regular surface. As far as the power problem is concerned, they don't want it to go up there and run down power almost immediately because it's on all the time, so they can turn it off and just turn it on when it needs to be moving and taking measurements. So in theory, it could last in an under ice environment for months. So that's pretty cool. And here's a few facts about this prototype that they've been working on for over 10 years now. It began underwater testing up in the Arctic back in 2012. It's only about 3 feet long, and it has 2 wheels that are about the size of large pizzas. So, you could have one of these in your bedroom. It uses an air-filled cylinder in the body, and there's also closed cells with foam in them in the wheels to maintain that buoyancy that will keep it up against that ice ceiling. It carries lights, cameras, and communication equipment, and it also can be outfitted with various scientific instruments, and it has been when it's been doing these prototype tests up in the Arctic and the Antarctic. So it can test. Actually, one of the things, and you'll hear about this in a video in a minute, that they've been testing for in these environments is methane seepage, which is important to in Earth environmental studies. To find out things that are going to affect climate change. And one other thing is that in the last test that I know about that happened in December 2019, and I'm sure there have been more since then, but there's not much out there on the internet. They put it through its paces for several 3-hour submersions, and a fourth one that they pushed it, and it lasted 42 hours plus. So what they're working for in anything that goes out to Europa or Enceladus is a vehicle that can last for months, so you can get a lot of good scientific data from it. All right, and that's a picture of BRUIE sitting up on top of the ice at one of its test runs. So I'm going to run a video here, and it's going to tell you quite a bit about BRUIE. And LB, if this is too loud, let me know right off the bat so I can turn it down a little bit.
Actually, Jeff, we can't hear the volume at all.
Oh, really?
Maybe we can narrate
Okay, let me go back.
Or if you want to, you can start over with the screen share and just make sure you click the checkbox beside share your
You know what?
audio too. I always
I,
forget to do that.
I didn't do that, so let me do that right now. Let's see. I don't want to do new share. All right, hold on one second.
We can share options. And I just want to let you know, we've already got some engineers in the chat here that are thinking about the problems that BRUIE is going to have.
I'm sure they're thinking ahead. Yeah.
Yes. Yeah, they are.
Let me.
Jeff, you can do a new share.
I'm doing that right now.
Yeah, and one of our moderators has just shared a link to the video that so you can watch it again later if you need to.
All right.
Go ahead.
Yeah, I've checked the sound, so yeah. All right, I'm going to start it again. All right, tell me if it's too loud. And can you hear it?
One environment on Earth that might serve as a useful analog for the exploration of Europa's ocean, which is trapped beneath a pretty thick ice shell, is the Arctic. And so our team developed this under ice rover to study these methane-rich lakes up along the Alaskan permafrost.
Here we're just taking an expedition out to a northern Arctic lake up near the northernmost point in Alaska. So we're driving on snow machines out to take our robot underneath the ice. Sub-zero temperatures, Arctic ice, biting winds, polar bears, and robots. God, I love this job.
The early testing we did tethered, which is our lifeline back to the surface. We didn't know whether this thing is going to sink or float, whether the systems were going to work. And so we're checking out the wheels, the cameras, the lights, just making sure everything works before we go wireless.
And if we do eventually deploy in a world like Europa, we're not going to have a tether. We're going to need to be able to do remote operations untethered.
Now, we specifically go out there during times when the ice is thin to find out where these methane seeps are. I'm actually poking at the ice, trying to find a trail for us that is safe for us to deploy the rover on.
Yeah, it's dangerous business walking around on this thin ice. I mean, this is why we thought of the rover to begin with. We thought, oh, well, just invert the surface. Instead of a rover that drives on the ground, we'll have a rover that drives on the ceiling. And what do we need to do that? We just make it buoyant. So it floats and essentially drives on the ceiling, which is the ice surface. Here's a good shot of a methane seep, where it's actually bubbling up from the lake floor and keeping the ice from freezing right there.
And the two different side lobes of the rover can be controlled independently. And so the cameras can look down at the lake bed and map out where some of the methane seeps are forming. And they can also be turned up to look at those methane bubbles and study what's actually happening at the ice-water interface.
And so the rover just drives right along upside down using buoyancy instead of weight, and gets up close and personal to be able to image and also sample these methane bubbles.
The later testing we've done untethered, so the rover is communicating through the ice back to a base station, and then from that base station up to satellites, back to operators at JPL or really anywhere in the world. This is about the closest you can get to Europa-like operations on Earth.
Our research up in the Arctic has this win-win where by studying the methane that's trapped in these lakes and coming out of the permafrost, we're helping to quantify the greenhouse gas emissions that are affecting climate change, while simultaneously building a vehicle and a scientific platform that serves as a precursor for something that may someday fly to Europa or Enceladus or one of the other moons that harbors an ocean.
Okay. I have one more video to show you now that will show you under ice operations from BRUIE's point of view. So we'll do that now. And if you look close enough, you can see some little fishies come swimming up close to the camera. There's a good look at one. maybe we'll see something like that in the waters of Europa someday. All right, and I'll just reiterate what I believe Kevin Hand, the lead project scientist, was saying in that video, that this prototype is actually serving a dual purpose right now. It's actually doing Earth environmental science when they go out and do these tests, and they're also, developing it as something that could be used in an extraterrestrial environment. So I think that is worth noting. It's helping us to learn about climate change on our own planet. And that's a good shot of BRUIE down there going through its paces. So I heard that some engineers were bringing up other possible or definite problems that have to be solved in order to make a mission that studies the under ice oceans on these worlds happen. And of course, the key one is, how do you get down there? How do you get through the ice? And I'm going to give you 2 or 3 concepts that are being worked on right now to try to get us through the ice shell. And one of them is called CryoBot, and it just essentially is a way to melt your way down through the ice using a heating element that is powered, in this case, by nuclear energy with a radioisotope thermoelectric generator. Yeah, that's one way to get through, but I'll tell you one way that if you're only using heating technology to get down there, you may encounter some problems. So I'll go to this next one, which is called Ice Mole. It's a variation on that theme. It does have a heating element here. It also has a drill. And the reason for the drill is because you can heat your way through ice, but if you hit a patch of soil, mud, you're not going to be able to heat your way through that. So the drill will help you get through any areas like that. And I guess there might be some rock too that you'd have to go through. And this particular variant is interesting in another way because it can change directions. If the people running the probe find that it needs to change directions for one reason or another, it can do so. The regular CryoBot just goes straight down. But this one has heating elements on various parts of the probe, on the sides and such, so that if you decide you want to go a certain direction that you're not going, you can turn on those other heating elements and shift your direction. So, and then there's Valkyrie, which is another variation on this theme. And instead of just a heating element, it actually uses lasers to heat up the ice in front of the probe. And they have found that they can go through the ice faster using lasers. But one thing, they were trying to avoid using the nuclear power option in this one, but they were using lasers to power the thing. And they couldn't get enough power, so they're kind of back at the nuclear power option. Last I heard, that's where they were. So they're thinking through this problem, and I'm sure they'll come up with the thing that works the best over the long haul. Now another problem that has to be dealt with, and I bet you the comments already show in the chat probably show that people are thinking about this too, is communicating through like several miles of ice. And this one here is a concept called TunnelBot, which again it would heat its way through the ice, but as it's going through, it leaves a lander on the surface with communication equipment on it, like a high gain antenna. And as the TunnelBot goes through the ice, it leaves communications transponders every few miles. And they're connected with a fiber optic cable, so that signals from down in the water could actually go from transponder to transponder and then to the landing vehicle so that you could communicate with Earth. And from what I read, if the cable breaks somewhere along the way, they can still communicate with each other. It would be better if the cable doesn't break, but they can still communicate with the ones that are, at various places above. So they're working on all angles of the engineering problems that will need to be dealt with. And so this is another picture of BRUIE out on the surface with a friend that you can see there in the background. All right, so this is a thought from Kevin Hand, the lead scientist on the project, trying to give you the long range view of this, that not only do we have to develop the technology and solve all these engineering problems, but we have to, while we're doing that, we have to send other vehicles to Europa over the next 10 or 15, 20 years to learn as much as we can about the environment that something like BRUIE is going to be in when it gets there. We need to know as much as we can about the thickness of that ice, where there are some places where it's not as thick, that'd be a little easier to get through to the ocean, and need to know about surface conditions. So, we've got at least 2 missions that are going to come before anything involving something like BRUIE. And this is a picture that I found that I really like of 2 of the team members from BRUIE at Casey Station in Antarctica during the test that they ran in 2019. You may have seen this, the photo of the milepost that people put, the direction and the mileage back to their home when they're working down there. And the BRUIE team decided that they needed to add Europa down there at the bottom, pointing straight up as a destination they want to get to. So I want to leave you with a couple of things before we get to questions, but one of them is a quote from Neil deGrasse Tyson, astrophysicist, who was asked if there was one place he had to pick, just one, in the solar system that he would like to visit. And this was his answer, if he had to pick one place to visit in the solar system. Right here. And I like his ice fishing on Europa comment because, I think when we get there, I think we're going to find more than microbes. That's just me, and it's just my opinion. And but I just think that if an ocean has existed on Europa for millions of years, it's had plenty of time for life to develop and get a little bit complex. And I didn't mention this earlier when I meant to, but that they believe that there is like 3 times the amount of water as there is in all of Earth's oceans combined under that ice on Europa. So that's a pretty big environment. So yeah, I like the ice fishing on Europa comment. And finally, if you're interested in kind of thinking about what we might find in those waters of Europa when we go there, I want to recommend a movie to you. It's called Europa Report. Probably some of you have already seen it. It's an interesting film, and it kind of goes against the grain of science fiction movies that have been made, probably since Star Wars, which I don't really consider to be science fiction anyway, but it's more science fantasy. But, there's so many of the science fiction things that are out there these days depend so heavily on CGI and on lots of things blowing up, and they don't really focus on the story very much. Well, this is about the first human mission to Europa to see if there's life there and what kinds of life might be there. And I won't give any spoilers away because you should see it yourself. But it's very understated, and they focus on the characters and the mission they were on, and if you're interested in this sort of thing, then I think you'll like it. So I believe that LB has shared these links in the chat, but if you want to know more about this project and things relating to this project, here are a few links for you. The first one is the JPL webpage for BRUIE, and then the second one is that first video I showed you. The third is to the Ocean World Lab page from JPL, and there's a lot of stuff about the guys on this team and what else they're looking into besides BRUIE. And the last one is a National Geographic article about what kinds of life we might find on Europa. And I believe that LB also shared a link to an interview with Kevin Hand that was all about the Europa report film. He was actually one of the chief science advisors for that film, and he really worked with them to try to get the science right in it. And he says that they did a good job, and that as far as what we know now about Europa, he managed to talk them into getting a lot of that in there, about how we would do it and what we would find once we got there. So it's a good interview, and he seemed pleased with the movie. So anyway, I'm open for questions now. I can't guarantee I will be able to answer them, but
Jeff, we have so many questions. Many questions. So many good questions too. I'm almost overwhelmed. First off, we have a participant who is pointing out that Europa is much bigger than lakes, and they think it would make sense for us to deploy several BRUIEs in one launch. So is that the plan, or do you think they'll just use one?
Gosh, that would all come down to funding, how much money was available. I'm one of those people who think that we should have a whole fleet of spacecraft going out into the outer solar system to, orbiters, landers, everything else. But, money is involved. And I think it would be great to go to different parts of Europa with different BRUIEs, so we could get as much information as possible. But I would say, based on, what NASA has been able to get approved, and how much budget they have, that the most you could hope for in something like this, which again would be about 20 years or more in the future, would be maybe two. Because they used to do that with Mars missions. They don't do it so much anymore. They used to send two orbiters or landers to Mars at a time in case one of them didn't make it. They would have redundancy. So but good question.
Yeah, very good question. And so so you said the launch date could be like 20 years from now. Is that?
I would say, because they've got to get all the data they can from Europa Clipper, which probably won't even get to Europa and Jupiter, and until, if it's launching in 2025, I don't have the arrival date at my fingertips. I'm sure that was covered in the talk that was given on Europa Clipper, but probably 2030-ish before it gets there, and they got to gather a lot of data, and then probably a lander after that. So that's probably another 10 years. I'm sure they'll develop it in the meantime, but 20 years may be optimistic. I'm hoping I will be an older guy who is paying attention to that when it happens. So.
Yeah, I would love to see that in my lifetime for sure. And speaking of landers, Keenan had a great question. What type of rocket would be used for BRUIE? How would it land on the surface? And I don't know, or we don't know yet, is an acceptable answer.
Yeah, we definitely don't know. They're working on concepts right now. So the launch vehicles, they'll probably have some launch vehicles then that have greater capacity than what we've got now. Like what they're doing at SpaceX is, they're doing some phenomenal things with developing new rocket technology. So I'd like to think they would have a heavy lift vehicle that could do this by then, that would shorten the time that it would take to get there. Because that's the key. The more lift you have in your launch vehicle, the shorter the period of time it takes to get out to Jupiter and Saturn. So I can't really answer that question because I don't think anybody knows the answer right now.
Yeah, that's okay. So are they developing BRUIE to be used on both Europa and Enceladus? Enceladus? I always do that. Sorry. Enceladus.
I think it could be used on either. And I didn't mention some of the other worlds out there that they think have oceans, but I mean Pluto. They're pretty sure Pluto has an ocean. It takes a long time to get out there, but I believe Ganymede they think might have an ocean. It's another Jupiter moon.
So this could be like a general, ice.
Yeah, they're finding lots of these things out there, and they never even. I don't think that thought occurred to anybody, before they found it.
Yeah. So I know you told us that BRUIE is the size of a large pizza box.
Well, the wheels are, yeah.
The wheel, just the wheels are. Okay, so can you describe real quickly, the size and the weight of BRUIE for us? Just remind us.
It's 3 feet long, and I neglected to find out how much it weighs, but I don't think it's a very heavy thing. I think they were carrying, you may have noticed they were carrying it covered up on one of those sleds up in the Arctic in that video. So I imagine they just pick it up and put it on the sled. Now an actual flight article that's going to Europa or Enceladus probably is going to weigh. It might even they might even like increase the size of it because this is just a prototype. It could be a lot bigger, and they will have to make sure they have room for all of the scientific experiments that they will load up into it too. So I'm guessing it won't be this little 3 feet long test article.
Mm-hmm.
Yeah.
Do you know if we'll be able to control it with a remote control?
Oh, you will. I worked on this problem with the other presentation I have on Dragonfly, which is tomorrow at 4:30. If anybody wants to tune into that one, but these things have to be autonomous because there's too much time between the time a radio signal is sent from Earth until it gets there, and then you have to get one back as well. For Dragonfly out at Titan, which is further out than Europa is, it takes. Let me look at my notes for that one. It takes to get a radio signal to Titan. It takes anywhere from 71 minutes to 88 minutes one way. So you can't send a signal and then wait for it to happen and see the video. I mean, double the time because it has to come back. So that drone on Dragonfly flies itself. They tell it what to do in advance, and then it does it, and it uses pictures that it took when it was up in the air before to tell it where to go. It does that itself, and so you're going to have autonomous operations with something like BRUIE too. It's going to have to just start going, maybe not go too far, until they get used to it and see what they see. But there's no driving it like on the Mars rovers. There's a few minutes that they have to have between the radio signals, so they can drive a little bit, stop, drive a little bit more, and it's not an autonomous thing with the Mars rovers.
Mm-hmm.
So, yeah.
Well, that's really cool. And we've got about 10 minutes left to finish questions and wrap up, because I know y'all are excited. We've got trivia at 6 p.m. right after this program. So I want to make sure everyone has time to play. But let's get to some more of these questions. So Jasper wanted to know, what would prevent an ice geyser from forming when the hole was finished being dug or drilled, or however it is formed?
Wow, that is an excellent question. And I don't think I have the answer to that one. Uh, yeah, I think I did. When I did this thing 3 years ago, I was wondering about that myself. That maybe it would just get shot right back out the hole. But I don't remember the answer that I found. I'm sorry. I'll have to go look into that and put it in the next version of this. But that's a great question.
That's okay. Yeah, that's we all can look things up and do some of our own research. I know I'm already more curious about things and have my own questions. Jasper also wanted to know if it takes samples on its own, will it get samples from inside the ice as well as the water or the ice water barrier?
Yeah, I believe it actually is doing things like that in the Arctic and the Antarctic tests. So yes, it will do that. And there's no good reason to go through a lot of material and not sample it and figure out what it's made of. That would be a wasted opportunity if it didn't do that.
Yeah. So let's see. LP just asked, would the openings created by the ice geysers be large enough for a probe to enter? Like maybe we don't even have to drill our own hole.
Well, those freeze up again. But that's one thing. That's one thing that a landing probe that isn't going to try to get underneath the ocean. I mean the ice. If there are in fact ice geysers on Europa, and we know there are on Enceladus, we should send something close by to sample material that's lying all over the place on the surface. You could possibly find some dead life forms, however small, however microscopic, right there, that have been blown out and fell back onto the surface. That'd be a pretty easy way to sample that stuff. And as a matter of fact, I have heard that whenever they get around to sending a follow-up mission to Enceladus, and I can't understand why that hasn't already happened, but they're going to have some pretty sophisticated equipment to sample that stuff that comes out, probably in an orbiter, but they might send a lander to do that as well.
We've got some questions from YouTube. So Peter wants to know, how did the water get on Europa?
Well, how did water get on any body in the solar system? My understanding is that scientists don't think the Earth had water on it when in its early, days after it coalesced into something like a planet, and that the water was brought there, by many thousands, maybe more than thousands, collisions with asteroids. That it was just an accumulation. So if they think that about Earth, I think they probably think it about other bodies as well.
Yeah, for sure. Yeah, Stephen points out, get a lander and we might find out. Good point.
I'm right there. I'm right there.
So Nashvi from YouTube asks, can you expand more on how BRUIE conducts research on methane on Earth?
I can't get too deep into that because I didn't read too much about it before I did that, or while I was doing this. But it's down there observing how it's seeping up from the floor. So it's giving them data via images on that, and I believe it is also sampling those when it's down there, sampling the deposits that are floating up and bubbling, to the surface, so that they are getting, I think, good data on how much is coming up from various spots. And methane is something that heats up, as you saw in that video, the ice, and melts it. So that's not so good for climate change. It is increasing the melt. As methane is released, it goes up into the atmosphere, makes things warmer.
Gotcha.
Yeah.
Okay, just a few more questions. Peter asks, how long is the trip to Europa?
It depends on the launch vehicle. Um, uh, when we sent New Horizons to Pluto, we sent it on a very fast launch vehicle, and we actually cut. I don't remember if it was. I think it was like 2 years off the time it would take to get to Pluto, because we sent it around Jupiter and used that gravity assist from that. I mean, Jupiter is a monster as far as gravity is concerned, and if you go around it just right, you get that gravity assist, and it sped up the spacecraft. So you can't use Jupiter for a gravity assist if Jupiter is where you're going, but if you use a bigger launch vehicle, you can get there a lot faster. And at one point, I heard Jamie Radeball was talking about this. My co-presenter tomorrow, she's a scientist on the Dragonfly mission, and she was hoping that Dragonfly would be put on the SLS that NASA has been developing for way too long. It's a monster rocket that is it's somewhat equivalent to the Saturn V from the old days, and it would have cut the travel time to Titan, way down. But that's not happening. We're not sure how many of those SLSs are actually going to be made, or if that program is going to end up being canceled or what, but can't really count on that one. If we're lucky, SpaceX will develop a really heavy lift launch vehicle, like I was saying earlier, and we can buy one of those from them and send it up there, and get it there in a couple of years, and not 4 or 5 like it takes with the smaller lift vehicles. So yeah.
Gotcha. And this will be our last question before we say goodbye. Stephen wanted to know, has BRUIE climbed any icebergs which under the water would be like mountains up from the ice?
I don't think they've gotten into anything that ambitious yet. They are, sending it down into places where they feel like they can retrieve it pretty easily if it gets into any trouble. As you saw, they actually, in the first tests, they were using a tether to make sure that if anything went wrong, they could just reel it back in. But I think they don't use the tether much, if at all, anymore. But they're still in the relatively early phases of testing, so nothing too ambitious. They don't want to lose it.
Right. And Stephen pointed out that it will be harder, probably, because BRUIE is going to have to handle, floating on the ice while also traveling down. So, yeah, quite a challenge. Well, thank you everyone so much for joining. Jeff, thank you for sharing your expertise and giving us lots to think about and get excited for, even if it is, decades away from launching. We do have trivia at 6 p.m. So our moderators will put the links to that in the chat. You do have to register for trivia, and you will receive the code and everything once you join. I also want to remind everybody that we have Astronomy Days t-shirts for sale right now if you'd like to commemorate your awesome time this whole week during Astronomy Days. And I do want to say thank you to our sponsors for this event, Pepsi and North Carolina Space Grant. And of course, I want to say thank you to our Friends of the Museum members who support us every single day. We greatly appreciate you. And again, thank you so much for joining us today. I hope everyone has a great night.
Thanks, everyone.
And join us again tomorrow. Thanks.
All right.
Bye.
Bye.